Hello and welcome to week 3 in Statistics for Psychology. Now, I'm hoping that last week you were able to get yourself familiarized with the workings of our Excel tool and the plugin that we have, and that's going to be kind of the standard of what we're going to be doing. This particular chapter, we're going to be looking at data and distributions, the second chapter in our course, and we will be using Excel again, but we will not be using the plugin. We're going to be doing some tools simply within Excel in order to create some ways in which we can take a large set of numbers and display those numbers or talk about those numbers in terms of the frequency of different scores. So let's take a look here at chapter 2. We have, of course, I go into in the attention section, going into the difference between data and anecdote. This is a philosophical sort of part of what we're doing here, is moving away from our personal understanding of the world, that internalized schema of our understanding of the world, moving beyond that into the world of science that says, okay, I understand what your personal experiences are, I understand how you feel the world works and the connections and whatnot, but we're going to let the data speak. And even if you've had tons and tons of experience about something, it still doesn't trump data. And that's a philosophical lens that we use in the field of psychology. So we go into the chapter first talking about variables. Now, variables are the individual concepts that we feel and are related to each other and have cause effects on each other. Each one of those things, so like intelligence or personality or skin color or race or any one of those are what we call variables. Those are the things that change. Either we want to see something that is affecting something else and producing change over there, or there's a numerical relationship between values on those different variables. Now, when we're doing a study, let's say we were going to make a very simple correlation study about intelligence and about grades, success in school. So we think, for example, that people of high intelligence might have a hypothesis. People with high intelligence are going to do well in school. So I have intelligence and academic performance. I want to see if there's a relationship between those. Those are my variables. They're called intelligence and they're called academic success. I then have to operationalize that, and that process is when I'm going to be very clear, what do I mean by intelligence and what do I mean by academic success? Because there may be more than one way to measure those particular variables. So this process of identifying your variables and then creating an operational definition for them, let's say I'm going to take intelligence and I'm going to say intelligence is going to be measured by the score on your IQ test, on a standardized IQ test like the Wechsler test. The academic achievement is going to be measured by your grade point average. So those, I go from variable to operational definitions. As we make our way through this class, and this has a little bit to do with research methods as well, we usually identify our variables and then we identify our operational definitions of those variables, and then we produce our hypotheses where we make an educated, informed guess as to the relationship between the two operational definitions, not the two variables. So the variables are intelligence and academic achievement. The operational definitions are IQ and GPA, and my hypotheses are going to be written about IQ and GPA. I might say those with high IQ will also have high GPA. I don't say those with high intelligence will have higher academic performance. The hypothesis reflects the operational definitions. So I go into that into here. So just had that sort of thing, and then we look at when we are defining those operational definitions, we are introducing scales of measurement. As scales of measurement, there's 4 kinds. There's nominal, ordinal, interval, and ratio data. Nominal data, it's names of things like the list of schools that you went through. Ordinal means sort of like letter grades, A, B, C, D, F. Intervals might include ratings on a personality scale. That's a Likert scale. It's numerical categories without a true 0 point. So, 1, 2, 3, 4, and then ratio data, which is, like say age, temperature, height. There's a 0 point related to the other figures. It's important for you to understand your variables, your operational definitions, and ultimately your hypotheses, and then the scale of measure that you're using. What, in terms of your definitions, what is the scale? Because the scale determines what statistical tool you can use. So if I'm going to try and find out that there's a relationship between my variables, I'm going to operationalize those variables. I'm going to create a hypothesis based on those operations, and those operational definitions define the types of data I'm going to have to deal with, and that leads me to the decision as to what statistical tool I'm going to use. Good stuff. All right. So you move forward here into, and I introduce you to frequency distribution. This will be our first statistic, and I'll do it simply. Let's say you're looking at a class, and you're looking at the final grades in the class, and I'm going to use ordinal data. How many A's, how many B's, how many C's, how many D's, and how many F's? One picture of that data of grades would be the frequency of people getting A's, the frequency of people getting B's, C's, D's, and F's. And I could chart that out. I could produce a bar chart showing how many people in each one of those categories. So this is what we're going to be focusing on for this particular chapter, is creating frequency distribution tables and charts. So we're going to have a whole bunch of data, and then we want to know how many of each type, of each score that exists, and then we want to create a table that represents that. And we're moving from just this list of numbers to a table and picture that portrays the distribution of those scores. So we end up with something like this. We have the distribution, the hours of sleep at night. Then you look at the table below that is the score on the left side and the frequency. So how many people scored 5? How many people had 5 hours of sleep? 2. How many people had 6 hours of sleep? 4. How many people had 7 hours? 6. And then we produce a chart that gives a graphic representation of the frequency of each score. You're going to be producing a document like this. So you look at what happens in the actual experience of this data. When if I just gave you those numbers along the top and said, what can you say about this? Not a whole lot. Turn that into a distribution table, and then turn that into a chart, and it kind of gives you a feel for all of this data. Okay? Now, the rest of the chapter goes a deep dive right into screenshots with Excel and using the tools within Excel to create your own frequency distributions. Keep in mind, on page 48, I go into the notion of how do you get Excel to give you a range of data. So in this particular, how many people are 5 to 6, 7 to 8, 9 to 10? When I'm grouping together, I have all these numbers, how many people fit in each group, And the way to do that in Excel, it has to do with some greater than and less than signs that you actually type right into the cell. So make sure that you take a good look at that particular part of the course book, because the assignment is going to have you do exactly that. I also get into the concept of cumulative percentage and then creating a bar chart. Now finally, we look at some interpretations of the bar chart, the kind of curve that it gets represents. You see we have on this down here on the left hand side, we have this distribution of hours of sleep at night, and it creates sort of a shaped mountain, and the peak of the mountain leans a little bit to the left, and we talk about that as a skew. This has a positive skew. Skew means is where the tail is heading. So if you have a bump on this side and the tail goes this way, the direction of that tail, whether it's positive or negative, is the skew. It's almost intuitive to go with where the bump is, so that something on this side would be a negative skew, but it's actually the opposite. So we have skew, we have how equal is the distribution around the mean, those kinds of things. So we'll be getting more into that as the chapters come up. So I'm asking you, in terms of the assignments for this particular week, the discussion is to look for charts in the media, frequency charts in the media. Find one, talk about it in the discussion. And then I have you do a quiz. Now this is going to be focusing on the identifying variables, operational definitions, and types of data. So I'm going to be asking you to do that. So I give you three. Well, the first question is, the frequency distributions are descriptive parts of our statistical tools. There are also predictive aspects there are predictive statistical tools. What's the difference? So you might have to look that stuff up, find out that difference. That's question one. Question two, I'm asking you to look at 3 studies, and I'm asking you to identify the population that we're interested in, the operational definition of the behavior, and identify the scale of measurement. What scale is it? That nominal, ordinal, ratio, which one of those is it? So there's right answers in here. This is not just opinion. And that's the quiz. And then the assignment, we go back into Excel. I again give you a set of data. You have to download that data. It's in Excel format. You're going to be looking at that data, and you're going to be producing a frequency distribution table and chart based on ranges of the scores. Now I'm looking at, it's actually A, B, C, D is how we interpret those scores, but the ranges are numbers. So A is all the scores from 90 to 100. So in your Excel formulas, you're going to have to use greater than and less than intelligently to make sure that you're getting everything from 90 to 100, but nothing below 90. And the other one is 80 to 89. You get nothing below 80, nothing above 89. Just get them. Okay, so you have to use some logic in how you use those greater than or less than signs. Okay. Then you're going to create a bar graph, and then just like all the other assignments in this class, you're going to be submitting the Excel file with the title page, data, and then your results in different tabs like that. Learning that skill again more and more as we make our way through the class. So that is what we're doing this week. So have a great week. Dive right into this. If you're having trouble with the Excel file, and I'm going to be doing the initial grading on the first assignment. Here we are in our second assignment using Excel. If you have not been able to get that plugin to work, we need to get together. We can do a Zoom meeting, or we can meet face to face, or I can just send you some instructions. We need to get you rolling on getting into Excel, because almost every chapter in this course has you producing an Excel document. So you're going to learn to love Excel. It's a great, great program. So with that, I'll leave it to you. Reach out to me if you have any questions. Have a great week and take care.